Hello class, and welcome to our second installment of Radical videos. Today we're talking about adding, subtracting, and multiplying radicals. This is going to involve several of the skills that we used when we just simply reduced radicals. We're just applying some more operations to them. First, when we add or subtract, the radicals must be the same, which means that if I have like 3 radical 5, or 3 square root 5, plus 2 square root 5, that is 5 root 5. It's not 5 root 10. Okay? You only add the numbers out front. It's almost like you're adding 3x and 5x to get 2x. Or 3x and 5x to get 7x, or something like that. So when the radicals are different, like 3 radical 10 plus 2 radical 7, you can't combine these. It is not like 5 radical 17. That is not a thing. When you're doing this, you just end up saying, if you didn't want a decimal approximation, you would just stop right here, and this is the answer. There's nothing really you can do. You can only add or subtract radicals when the radical is exactly the same. The number out front can be anything, but the number inside that radical, the radicand, has to be the same for all of the numbers you're trying to add or subtract. So in this case, with this example, I have radical 20 plus radical 125. Well, I can't add these right now in their current state. But perhaps if I reduce them first, then you might be able to combine your radicals after you're finished. So radical 20 is the same as saying 4 times 5. Which the square root of 4 is 2, and the square root of 5 is 5. And then radical 125, it's divisible by 25, because it ends in the 25 right there. So this is radical 25 times 5, which is the same as saying 5 root 5, because the square root of 25 is 5, and the square root of root 5 just stays root 5. So then we end up with 2 root 5 plus 5 root 5. Well, since now we have our radicals expressed as the same number, we just add the two numbers out front, and we say 7 root 5. And that's our answer. When we reduce our radicals first, we end up in a situation where we can combine the numbers in front of the radicals together. Again, this 5, this radical here, does not change when you add radicals. Let's try the next one. I have radical 10 plus radical 90 minus radical 75. So currently I can't do anything. I have to try to reduce. So radical 10 doesn't reduce, it just stays radical 10. So I'll keep that the same. Radical 90 is the same as saying 9 times 10, radical 90 times radical 10. Or radical 9 times radical 10. So this is radical 9, which is 3, and then radical 10. And then 75 is the same as saying 25 times 3. You take a radical of each one of those. So you have minus 5 root 3. So then from here, all you have to do is combine the radicals that you're allowed to combine. So these two here can combine together because they are both radical 10. So remember, there's like an imaginary 1 here. So I have 1 radical 10 plus 3 radical 10, which gives me 4 radical 10. And then, unfortunately, this 5 root 3, it doesn't combine with the radical 10. So you just leave it. And this is your exact answer. You could put this in a calculator and get a decimal approximation, but that's not really what we're going for right now. You would just stop right here. when you multiply radicals, you really are just multiplying the like terms or the like parts. So if I have like 2 radical 7 multiplied by 5 radical 2, okay, you would multiply the 2 and the 5 together to get 10. And then you would multiply the radicals together. So 7 times 2 is 14. And then after you did this, if you could, you should reduce this problem more, which you cannot in this case, but sometimes you will be able to. This is a similar process if you were to square a radical. So like if you had 3 radical 2 squared. That's the same as saying 3 root 2 multiplied by 3 root 2, which is 3 times 3, which is 9, and then root 2 times root 2, which is root 4, and then here, conveniently, root 9 times root 4, well, that's the same as saying just 9 times 2, which is 18. So let's do a couple more examples. So here we have 3 times 5, 3 times 5, which is 15. And then we have root 2 times root 6, and 2 times 6 is 12. Now here is a situation where I want to try to reduce this radical if I can. 12 can be written as 4 times 3. So the square root of 4 is 2, and the square root of 3 is an unpleasant number, so we leave it. So then you can just do 15 times 2, which is 30, and then the root 3 stays the same. And that's your answer. Now this one, you have several options that you could do to try to solve it. Personally, since I am multiplying a radical by another radical, I find that it's easiest to actually reduce them first, because then I can do a lot more of the math in my head instead of trying to multiply 40 times 32, which is going to give me a rather large number. So I would reduce first. So root 40 is 4 times 10, which is the square root of 4 is 2 times root 10. And then I have root 32. 32 is 16 times 2, and the square root of 16 is 4 times 2. And so now I have a situation with pretty small numbers like I did up right here. I can multiply the 2 and the 4 to get 8. And then I can multiply the 10 and the 2 to get 20. And again, I am a good math student, and I want to make sure that I can't reduce my radical any further. And in this case, I actually can keep going, because 8 is multiplied by root 20, which is 4 times 5, and 4 is a perfect square. So 8 times 2 times 5. So this is 16 root 5. And again, you don't necessarily have to show all of this work, but sometimes it helps. And especially helping you when you maybe potentially make a mistake. So this problem might seem a little scary and tricky, but it's actually not too terribly bad. This is kind of combining an adding or subtracting problem with a multiplying problem. All the properties of numbers apply, so you can actually use the distributive property here. You're going to multiply root 2 times root 5, and then subtract root 2 times root 6, being aware that when you multiply radicals, you just multiply the radicands, the inside part, together. And then to be able to add or subtract radicals, the radicand has to be the same. So currently, I have root 10 minus root 12, which cannot be subtracted because they are not the same radicand. But I can reduce radical 12. Maybe that will help me. 12 is 4 times 3. So this becomes 2 root 3. It doesn't really help me add or subtract the numbers together, but this is my final answer. Again, I can't combine radical 10 and root 3 because they're not the same radical, so I just stop. This is the end of our second radical video. Feel free to ask any questions and begin work on your assignment and make good choices.